As per usual, please put your names on the agenda doc so that we know who's here.
Yes, finally.
Let's get started. I think there's one big agenda item that people were talking about. Is that the one that Christian you added, the blockchain structure?
Yeah. I'm currently in the process of just prepping it a little bit here, but yeah, that's the game plan.
Just put your name again, just so we know. So proposed. I can give some high-level updates.
Oh, wrong window. Okay. Go ahead. Yeah, give some high level updates just while I prep this a little bit more.
Yeah. So one of the things that I just for the broader group is that we have been working on figuring out what kind of data gets populated into the blockchain per se, and just learning from what we know already, building tools at JFrog. So some of that is being documented or was being documented a couple of weeks ago. So I think we have made more progress on that, but that is still a work in progress, and we'll publish something once we have that sorted out.
Okay.
And this is part of the data structures that you have been researching, Christian.
Yeah. So, all right. Let's start with a little sort of dissection here. I think there's some confusion around the word metadata, and I think I understand why. So it really comes down to perspective. If you are a user of the blockchain, then all the data you're giving the blockchain is metadata, right? We're not storing the blob data for an artifact on the blockchain. We've all agreed to that, which means the only thing left is to store the metadata about the artifact on the blockchain. So when the rest of the team uses the word metadata, that's what they mean. Internally, though, and this is something that we're discussing, if the payload where we store your metadata is just a hash slice or is just a byte slice, then that's a really opaque structure. And in order to effectively decode it, right, it's now no longer metadata to us, it is data. And in order to effectively decode it, then we would need our own set of metadata, right? And so I think there's some confusion here around that.
Yeah.
I'm going to share my screen with.
So will it help if we call it artifact metadata versus blockchain metadata?
Are you guys seeing my my IDE here? I can't tell.
Yes, the text is a little difficult to read, but I can see it.
All right, that's probably because let me make this, see if I can make this a little larger. View, appearance, larger. How do I make it be larger?
What ID is this?
This is Sea Lion by JetBrains. Can you guys, so is this better? You guys see
I think you need to press Control and plus. You need to hold them together.
Yeah, I was just doing that. It's not doing anything.
No, it won't do that on IntelliJ. So you have to go to Preferences, Editor, find.
There is a way to make this bigger. I'm just, all right, just give me 1 second. I have such a big screen.
No, Sudendra was just telling you, like, you just go change the editor font. It sounds like.
Yeah.
Oh, okay. Where?
If you go to preferences, I don't know where preferences are.
Okay,
Yeah.
preferences. Font, appearance, and
And then
behavior.
yeah, and then you can find editor and font and
Oh, okay,
that
size.
13 has to change to like 18 or something.
There we go.
There, yeah, perfect. Thanks, dude.
Okay. Yeah. All right. So now I'll go back to full screen mode then. All right. So what I did is I decided to kind of make the blockchain structure into JSON, right? It's going to be somewhat stored like that anyways, but I decided to make the current blockchain structure into JSON. It's a little bit stubbed in, but a little bit not, so that people could understand the layout. And so the first thing I'm literally going to do is I'm going to collapse everything, right? So first and foremost, the blockchain just has the local blockchain ID. This is its local ID. And I believe we're also using this as the node ID, one and the same, okay? And then we have the series of blocks, which is here. And I'm going to close this just so you can see that in this case, we just have a couple blocks. And inside the block, we have a header and a signature. And in the header, we contain all the necessary stuff in order to verify transactions. So this is kind of a shortcut way of not having to re-verify every transaction. We just do it one time and stick it here. So it's kind of a shortcut. It's a way for us to know what we have without transferring all the data. And the parent hash, this is, I don't have this in here, but the parent hash is really the fundamental core of what it means to be a chain. So when they say blockchain, this is the important part. Right, originally a blockchain was like a linked list, and it wasn't a forward linked list, it's a backward linked list. So you can start with the most recent transaction and work your way back to the Genesis block. Moving from the Genesis block forward is not possible, at least not in any implementation I know of, but it's still the chain, it works backwards. And so the parent hash is referring to the hash of the block before it, right? So in this case, it's in this long array, but it doesn't need to be in an array. It just says, this is my parent hash. The ordinal is important though, because that is the way these blocks are ordered, and ordering for us is super crucial. Transactions hash, this is something we've debated and gone back and forth on. Again, it's another way to sort of short circuit having to go through every transaction and recompute every hash. You just create one hash for all of them. Timestamp, we are working with Unix epoch time. A nonce, that should be nonce. The nonce is meant to help keep the security really tight by giving it a unique ID for every single one. So think of it like salt. And then of course, this is the entire block hash. So, and then we sign it here. So I'll let Chris explain it, but the idea behind signing of the hash is, again, for performance reasons. Transactions. So this is one of the things that is kind of like currently up in the air, right? And, I would encourage the team to sort of like talk through this, right? But there's some debate about whether we should have certain transaction IDs, like certain transaction types, or no transaction types at all, and you just stuff the data in, right? So the things we want to put in this blockchain are, we want to put keys, authoritative keys, and that's what these currently represent. And again, don't take this as gospel, because this is still currently under debate. But for example, we want to put keys in so that we know they're authoritative keys, and we want to revoke keys, right? So that they can't be used later, right? And this is the payload for each of those keys, for example, okay? But at the same time, we know that we also want to put artifact related metadata here. So like in this case, right, this is not JSON. This is actually binary that's just been base 64 encoded, or base 16 encoded. But in the case of, say, metadata about an artifact, that would basically be JSON. So the payload type, we can either normalize it and say it's all one thing, like a byte slice, and then, have to try and decode it. Or we can say it's all JSON, for example, and then everyone has to conform to that. But we have different ideas of transactions in the sense that not all payloads are the same. So here you see revoke authority, etc. But then in this one, did I put transaction type is add artifact? Now I cooked this one up for myself, okay? But the payload for an add artifact, right, is a whole bunch of metadata, which is basically JSON in and of itself. So some of our outstanding discussion points are, what should this payload be? Should it just be a blob byte array? Should it be a map, etc.? Because that's got some trade-offs. And what sort of transactions are we thinking here, or do we not want to even have transactions? So this is currently what's kind of under debate. But one of the things I want to emphasize here is the structure looks like this. You have headers, transactions, and signature. Multiple transactions, but one header. So blocks have header and transactions, and you can have multiple blocks. So I'm trying to spell out like how this thing looks by basically showing it to you in a JSON format. Some of these fields may change, but the structure, the overall structure is not. So that's kind of how I wanted to jump into this, get people's questions, get people's inputs, see what anyone has to say. I'm all ears.
So one thing I'm curious about is this entire structure meant to be streamable? Like, do you have to have the entire JSON from local ID to blocks to everything before you have the in memory? Like, I'm trying to understand.
So I know where your question's going. This is just a representation for people to get their head around. This is not.
Thank you. That's what I wanted to know. So it's not actually how it's written. It's just how it's represented for us. Awesome.
Right. So the current storage implementation is right TBD. It's entirely on us, right? But one could imagine, for example, each block being an individual JSON file or JSON document, each block. And because you have the parent hash, right, you can always look up the other block because you have the parent hash, right, which is the previous block. So you can literally just do a file lookup or a document lookup based on this field, for example. So this is just a way for people to get their heads around it, to see what's nested where, what the fields are, etc. I don't know. I would not imagine this to be stored on disk ever, regardless of who implements it, because a ginormous JSON document like this would be incredibly unwieldy. It would have all sorts of locking issues, and definitely on a file system like NTFS wouldn't work. So
that was the reason I was asking. Thank you.
Yeah, no, it's a good question, and I wanted to color in the details to explain why, or sort of thoughts on how it might be stored, right? Anyways, what other questions do we have for people?
So my question is mainly how, so without, I don't think we have to understand all the implementation details, but how can we use it? So suppose that we want to store something on the blockchain, is there some sort of an API, or how can it be used?
Yes, we are currently in the process of that, but let me see if I actually have the code behind it here, simple node. So, okay, this code will change. Okay, so don't take this as gospel. This is an iteration, but this code will change. And this is a chain, submit a transaction, get all the bytes. This is, again, currently how it's implemented. And then you give it a function, a lambda, that you want to have called when the transaction is complete. And because remember, transactions, they take time to settle. Simply because you added it and said, hey, I want you to store this, doesn't mean that it happens right away. And in fact, it can take some period of time depending upon how many nodes and how long it takes to settle. However, the idea is that once it settles, this function will be called. And it's when this function, and there's, by the way, there's one for listening for blocks too. So you can listen to every block submission as well. But the idea is that when the transaction is settled, you'll get notified, and then you can put it on the network. You can save it to disk. You can, call other parts of the system, et cetera, when the transaction is finally saved. Transactions in blocks settling is a very asynchronous event. So the idea behind having a Lambda is to capture that asynchronous so that the code itself doesn't have to sit around and wait. Does that make more sense?
Yes, it does. So that is then for storing, and then the difficult part then probably, and if we want to look something up.
The blockchain itself does not support and really has no intention of supporting any sort of search. And my understanding is that that was the whole idea behind having a document database. Is that, so for example, one could imagine that every time a transaction is settled, instead of saying artifact added, I would have doc db.submit, and then I would say, transaction.
Yes, so that is possible. And we can also search from the DB, but what if the database is compromised? So that's where I would assume that we can somehow check a hash with a hash from the blockchain to make sure that whatever we have in local storage is indeed what should be there.
I believe you and I talked about this yesterday, but the blockchain is the origin, is the master source of truth. The fact that there's a document storage database out there has an architectural problem in that if it's doing anything other than indexing, which is to say if it's storing effectively a copy of what's in the block, then that's a problem because the block is always authoritative, always.
Yes, that makes sense. But how do we know that? So it makes sense that the blockchain is the single truth of source of truth. But how do we know that any local storage or whatever is correct as well? Without
good question. And I would offer, not to be at all dismissive, but I would offer that's outside the purview of the blockchain itself. Whenever a transaction or a block is recorded, whenever it's settled, it can be written to disk, it can be written to a document store, you can do whatever you want, but the blockchain is going to maintain what it understands in memory. And when it starts back up, right, when you start it back up, the presumption is, of course, that it's going to verify all the blocks that it has as it starts up to make sure that they are in fact correct. But it's like, what if you compromise some other part of the application, right? I have a linked list and somebody hacks the memory and somebody changes a byte in memory. How do you know? You don't. So I would offer that that's outside the purview of the blockchain. However, when it starts up, right, it's obviously you would want it to verify all the blocks in the chain. Does that make sense?
Yes, so that means that we have quite a lot of work outside of the blockchain. That's okay, it's good to know.
Yeah, the blockchain's job is really to maintain the ledger and give the hooks for the rest of the system to deal with file I/O, verification. I mean, any data given to the blockchain will be verified, but once it's saved to disk, like it's out of our hands. What if the whole file system goes corrupt? What if somebody hacks the system? What if the what ifs go endlessly, right? But when the blockchain starts up, it can and will verify the blocks it's given. That is something I'm on board with. So
yes, so it only verifies its own blocks. Okay, and there's no way to query any transaction. Okay.
Well, in a blockchain to do that, by the very nature of a blockchain, the only way to do that is to literally go through all of them. which is grotesquely inefficient.
Exactly.
So I don't even pretend to address that subject because it's just not, it's a non-starter. So we don't even bother to discuss it because it's just not happening. So, you know, a document, if a document store is to be used, I would, you know, suggest that the document store itself do index, but not store. And that way, you know, you do the index, you do the search, and you say, give me, you know, give me all blocks that were created by this one key. And it says, okay, those are in blocks 7, 10, 9, 12, and 14. Well, then, because, you know, the blocks are, you know, saved to disk or something, or, you know, maybe you can ask the chain itself for a single block, but that's about it. Once you know the block, you can go get it, but the blockchain itself is really not going to manage any sort of searching capabilities at all. That's external.
Okay, but now I hear something something else that's really important, so that you can still query the individual blocks, and the blockchain knows the integrity of the chain, hence of the blocks.
It will
But nothing
maintain
about
the
blocks, so that makes sense. Yes.
It will maintain the integrity of the blocks that it knows about and has. Once it's been saved to disk, or once the application is shut down, the only time there'll be verification is on startup. That's it. All right. Anyone else with questions?
Yeah, I have a question. So you mentioned, you showed this structure, and you were talking about how this is not the format it is saved on disk, or this is agnostic to how it is saved on disk.
This is meant just for people to wrap their heads around the way the blockchain is structured and nothing more.
Yeah, but then this has to manifest itself in terms of how this data is shared among the peers, because eventually all of this needs to get shared among the peers. So in that case, how is it transferred over the wire? Is it going to be JSON? Is it going to be these payloads? And then on receiving, do the peers have to base64 all of that to read and find out what is happening?
All of the block transmission and settling is done through Aleph. Aleph requires, you know, serialization, and Aleph handles all the transfer. So really, as long as we meet the requirements for serializable, it doesn't actually matter how it gets transferred over. None of it, it will be entirely transparent. By the time this actually, by the time you get a callback for your transaction or your block, when you get a block settled notification, it may have and likely has come from an Aleph event that Aleph has agreed that yes, this block is good and we accept it. Then you will get a notification that a block has settled. So, but up to that point, how it gets transferred, it's immaterial. It could be binary data. It could be JSON. It's immaterial. It's going over the wire.
So now, we could choose to keep it in JSON, right? Meaning, because Aleph is going to take care of efficiency of that. So we don't need to bend over backwards to make it efficient.
No.
Right.
Like,
so we can keep it in JSON so that I can read it, correct? It can be human readable. We'll keep it in JSON and then let Aleph do its thing.
Well, let's keep in mind how it transfers over the wire and how it gets saved to disk need not be the same. So, you know, I mean, the only time I ever look at what goes over the wire is when I'm having a problem and I need to debug, and then I put like a wire sniffer in there. And then yes, I want it in JSON so I can, you know, understand what's going on, right? But generally speaking, I'm looking at files that have already been, you know, saved to disk, because that's the most natural place to look. So as far as it goes over the wire, I mean, if you really, really want to know how it goes over the wire, I'm going to guess it goes as JSON. I'd like, you know, Chris can confirm that, but I don't think it's material, you know, to how the blockchain operates. It's just Aleph does its thing. And when Aleph says, you know, transaction done, we say, great. And then we do our part.
And how about storing? Does Aleph take care of storing, or does it have a way so that it can manage storing, or do we have to write something?
It has hooks for I/O, network and file I/O. It has hooks, and it requires us to manage signatures. And that's basically it. So it's on us to decide how things get saved.
Yeah.
Does that answer your question, Suhendra? I know.
Little bit. It's yeah. I'm still wondering like how people who are using LF are building storage or how they are handling this requirement instead of everyone trying to invent it for themselves. Is there some implementation that we can just rely on instead of building a way to store this data? Because I don't think we are experts at understanding block level data storage. That's my
I mean, Suhendra, block level data storage is what we want it to be. If we want it to be JSON, I think everyone on this call at this point has mastered JSON, and I don't think we need to outsource our thinking on JSON. If that works for us, that's what we roll with. But how it gets saved to disk, that's not really where the true challenge is. The challenge will always be in the network transfer. Under some conditions, I could see it. I could see these payloads being what do you call it there? What's Google's super fast? Yeah, protobufs, right? Maybe data transfer could be protobuf, but if you save something to disk and ever need to look at it, then protobuf is dead in the water because it's basically can't be debugged. It's impenetrable. So I don't really think that that's a concern for us. We'll save it as JSON almost certainly. I'm right. It hasn't been implemented, so I'm not going to say, yes, we're going to save it as JSON. And then, geez, I changed my mind and you come back and rap me on the knuckles that I said we were going to do it in JSON and we changed our mind. But JSON is so natural these days. I don't see a reason we wouldn't save it as JSON of some kind.
Yeah. So yeah, so that's what my concern was. Like, why are we thinking about even base 64 in the payload? We'll just keep it as JSON and we'll just keep it simple so that we can understand code.
Suhendra, I don't think it matters how it gets saved. Yes, we're going to keep it simple because that makes our life easy.
Yeah.
I mean, what simple means is, it's simple to me if I'm the one writing it and it works for me, then it's simple, right? Like, I don't think we need a committee to determine what simple means. Keep it simple. This is simple, right? And each one of these blocks is basically this chunk of data right here. That I could imagine being in a single file.
So Christian, suppose we were talking about transaction type, and there is a transaction type of add artifact, which you said like, okay, it's custom designed. And so if we provide payload of any other type, would there be any verification on blockchain side, or we have to do outside of it before sending it?
So this is currently under debate, right? Because on the one hand, it's your data, not ours, right? On the other, once it goes into the blockchain, if it's total gibberish, it's total gibberish and it's permanently total gibberish. It is effectively dead data. It cannot be recovered. It cannot be fixed. It cannot anything. So
yeah, that is why, like, I was wondering about the verification.
Right, but if we put the burden of verification on the blockchain, that means that every time somebody wants to have a new data payload, then they have to go in, modify the blockchain, or create a new verifier for each and every one, and that causes consistent churn in the blockchain, which we don't want. It's really, the blockchain, it doesn't care what the payload is, right? The users of the blockchain do. So to some degree, yes, we should help facilitate management, but only to a minor degree, right? Very, very minor. It's hands off. It's like, would you expect Postgres to verify your data for you, right? No, you build in some rules, but like the semantic meaning of your data is always application level, always.
So I think the question is appropriate because we understand that, for Postgres, we don't expect Postgres to do anything more than what Postgres does. But as part of the application that we're building, I think this becomes a requirement that we have to build this layer, which can do the interpretation for us and not just say, okay, everything is data for me. We understand that, right? Meaning for Postgres, everything is data. For Aleph, everything is data. But what we are talking about here is actually the layer that translate that data into something meaningful for Pyrsia.
No, the blockchain is closely equivalent to Postgres in this regard. Like you can
Yes.
say this field in Postgres, you can say this field is an int, this field is a char, this field is a whatever. And you can even say, it has to be 12 characters. But if that has some sort of application level semantic meaning, you can't encode that in Postgres, unless of course you're writing like triggers and things like that, which is effectively putting application logic in your database, which is a poor design. So what we don't want to do is put application logic here.
Yeah, I'm not talking about that. I'm talking about the ORM layer that we put on top of Postgres so that we understand the data. So that is what I'm expecting us to build is the translation mechanism and make that blockchain, which is provided by Aleph, usable by Pyrsia. And that's where my questions are coming from, that how do I make it so that I can use it? I understand that blockchain per se doesn't care, but that is not the question at all. The question is, what are we doing to build that layer where I can translate my domain into what can be stored eventually?
Sure. No, that makes sense. I want to correct something you said, Suhindra, that is inaccurate, so the rest of the team doesn't get the wrong understanding. Aleph is not the blockchain. Aleph is the consensus engine. Aleph just takes all the blocks and says, okay, I just got these 5 blocks from all these different nodes, and of these 5 blocks I got, these 2 are good, these 3 are these other 3 are still pending. And by the way, one of them I just determined is total crap and I'm going to throw it away. But Aleph is consensus and consensus only.
Just to clarify that point, Aleph doesn't even work with blocks. It works with network data. So it doesn't even understand what a block is, to be perfectly clear on that. It's us who is implementing the blockchain on top of Aleph. So this distinction between the transparency log that we talk about and this marshaling and understanding of data, this ORM as you referred to it, is a layer above the blockchain. We are focused on building a blockchain, not necessarily the ORM that sits on top of it.
Okay, I think that is maybe the biggest thing that we have to realize, that that this ORM layer still needs to be developed then. And
yeah, I think that's what we discussed last time also, and we understood that I mean, some people have this thing that blockchain is doing most of the part, but later we realized that we don't have that thing yet. It's still for transparency log to be searchable and make it more structured and everything, and that is actually everything is outside of blockchain. So and we have to define that. And we also heard that blockchain will not be the part of MVP. So irrespective of, I think we just have to ignore that part and just build, that layer, irrespective of what blockchain is doing. So
exactly, yes.
Yeah, like if a layer on top of blockchain, for example, for search is required, right? I mean, that was the whole reason for, I think, implementing our, recreating our own document DB, was so that it could do the search, but then, then the primitive blockchain could just, you could just go get the blocks, right? But if there's to be some sort of ORM, then yeah, that would be layered on top. I mean, even as it is now, an ORM is an application layer on top of a database. The database knows nothing about an ORM and doesn't support it, not natively, right? So
what?
Steve, you had a question?
Yeah, no, I was, well, 2 things. One is procedural thing on the meeting. So do we want to switch to the call that you set up?
Well, actually, people asked me to extend it by 30 minutes. This call extended by 30 minutes by simply just abutting another 30-minute meeting.
Okay, all right, so we're extending this one out.
Yeah.
And the other one on the MVP, so I do think we need a transparency ledger for the MVP. So we should discuss what's going to make it in for the MVP, but I don't think it's enough just to go out with the peer-to-peer distribution system. That's not a real MVP.
Totally
Okay.
agree. We need a transparency log. I don't know, whatever you choose, but
Well, anyways, that's important, but I want to make sure everyone gets their blockchain questions answered here, and then we can talk, about MVP in a different meeting. So, because Suhindra, I know that we had a one-on-one last week where I gave you a deep dive on all blockchain, but you still had more questions. I want to make sure you get all your questions answered so that we can sort of put to bed a lot of misconceptions and a lot of I continue to just hear that people just aren't getting it. I want to make sure everyone gets their questions answered.
no, thank you.
This is the way it's intended to be interacted with. This may change a little bit, but the idea is you're going to give us some data and you're going to give us a function that will call when the data is settled. And when that function is called, if you want, save it to the file system. If we want, we throw it in a document for indexing. If we want, we print it to a log file, whatever we want. But the idea is that when it's settled, we'll call your function and let you know. Does that make sense for people? Do you understand why? People are in agreement? I want to make sure that, people get a chance to be heard and we're not, 4 months down the road and then suddenly hair is on fire. Okay. Silence is consent, as they say. So, Steve, do you have any questions? Suhindra, do you have any questions? Chris, do you have anything you want to add?
So as part of the Aleph implementation, there is also a blockchain implementation, right?
Yeah,
Aleph literature.
Yeah, so Aleph is going to send and receive data that just so happens to be blocks, and it's going to manage the consensus. When this data, aka a block, is determined to be, through consensus, yes, all nodes agree or enough nodes agree that this is good. When that happens, we're going to take that data and submit it into the blockchain here. And at that point, it can be saved to disk or whatever we want. But Aleph is just going to tell us when we have a chunk of data, aka a block, that's good.
So when people use Aleph BFT, do they use a specific blockchain implementation that we also can use?
No, you mean like out there in the wild?
Yeah.
No. I mean, there's Substrate, right, which uses Aleph. But if you remember from our hackathon, Substrate has the concept of coinage cooked right into it. And the overriding requirement was money is bad, get rid of money. So by going lower layer with Aleph, the hardest part is consensus. The hardest part of any blockchain is consensus. By going lower level and getting the consensus part solved, right, we are able to just not even deal with money. And shocking as it may seem, proof of authority which is what we're doing, is actually very cutting edge. No, IBM's Hyperledger claims to do proof of authority, but I've not actually seen that in practice. Everyone else is either doing proof of work, proof of stake, or some other crazy research grade stuff. But nobody out there is doing really proof of authority, which is what we're doing. So in a way, this is actually cutting edge.
So my question was related to, how we are using libp2p, which is part of the whole IPFS thing. But we just are interested in how the peer-to-peer networking works, and we are able to use that. So I'm wondering, with Aleph BFT, if there is such an implementation which understands how to store blocks and handle blocks that we can use. Are there libraries that you have researched that you have found useful?
Aleph is a consensus engine. It's not a
No,
blockchain.
I understand.
Right.
So
there does not exist anything related to blockchain around the Aleph consensus engine.
So Aleph is used for things other than blockchain, Suhindra. And so, like having a plugin library that tells Aleph to turn this into a block and transfer it as JSON, that would assume that Aleph cared at all about blockchain. It doesn't.
So the Aleph BFT website says that it is basically the consensus engine used by Aleph Zero Foundation, which does build the whole blockchain and the whole strata.
Sure.
Of
Aleph
things. So
Zero.
are there yeah.
Aleph Zero is a layer on top of Aleph.
Yeah.
All right. I have a question. So how does Aleph return data? So how do we process it? What is the way it returns data for us to put it in the blockchain?
When you say we as in anyone not implementing the blockchain, there is no we. You will never see Aleph. You will never touch Aleph. You will never care about Aleph. Aleph is an internal detail for how consensus is done. The block that will be cooked into the blockchain as a whole, and you will never know or care about it. That is our intention.
In the sense I meant Pyrsia developers. We as developers. I meant the unit of developers.
Yeah, you're not going to need to know about Aleph at all.
All right.
Not at all. It's like you have an API that saves a file to disk, and worrying yourself about how Linux implemented the ext3 file system for actually saving the file to disk. You don't care. It just works.
Understood.
To answer Suhindra's question about how the Aleph cryptocurrency works, right? So the Aleph Zero Foundation is building their own cryptocurrency, and they used Substrate to build their cryptocurrency. Now, for those of you who don't remember, because it's been quite a while, Substrate is a blockchain building framework for interoperable parallel blockchains. And as Christian so subsequently mentioned, it has a hard requirement of the notion of a currency, which is something that we want to do our best to avoid. And it's the reason why we're not using Substrate. We're not doing the same thing that the Aleph cryptocurrency is doing, but we are using their BFT, which is Byzantine fault tolerance, which is their consensus engine. Does that answer your question?
Yeah, a little bit. What I'm wondering is, are there things inside Substrate which can be pulled out and used?
No.
Which do not have the currency?
Not without gobsmack amounts of hours to tease out very little. Substrate, look, if we could use a currency, then Substrate would have been the way to go. Even if we could have just set all the costs of every transaction to zero and everyone has infinite money, all right, if we could have gone that way, then Substrate would have, Substrate was basically turnkey. But because we are, we have been told money bad, we've gone lower layer, and that's why we use Aleph just for consensus, because consensus is actually the hardest part. Getting a whole bunch of random nodes to submit data at each other, look at it, settle, decide, vote, verify, validate, and then come to an agreement is like the stuff of like many PhD research dissertations.
So I think you have made the point that consensus is the hard part. So if consensus is the hard part, and we have chosen a technology that implements consensus for us, the easier parts comparatively are the storing the block and retrieving the block and building the blockchain, right?
Yep. And to this end, right? Storing a block, we can store a block any way we want, right? Store it as a JSON file on disk. Great. And you can make the file name be the block ID. That's up to us. And I just can't imagine someone would roll a library to decide how we should do that, because it's so easy. Like saving a file is effortless.
Yeah. So that's my question. So if those are the easy parts, do you think they can be built in shorter time than and be ready for the MVP? That I think that is where we're trying to go.
Later today, myself, Chris, and Shufei, we have a meeting scheduled specifically to discuss what's part of our demo, what, focus on that and make sure we're all in agreement and execute forward, right? I mean, asking me that kind of question in this call kind of puts us all on the spot because it's, Steve, right, injected, like, hey, we need this for MVP. So the three of us are going to have to, discuss that and be like, okay, can we do it? What do we, what can we include? What can we not, et cetera. So you're kind of putting us on the spot. I don't have an answer for you.
Okay. No,
So
my question was more open, like based on the conversation that we were having, that the difficult parts we have chosen a library to do, right? So the easier parts, or relatively easier, I don't want to say easier, period, but easier than building the consensus engine. So how, do you like? I think that is the next step then to figure out what the complexities around that are estimated and start building those. Because based on what you just said, consensus is a solved problem, right? We are just going to use whatever LF is built for it.
We can't hear you. You're too far away from your mic.
Sorry. Actually, I'm on my headset. Okay. Anyways, maybe the headset is doing some noise.
Consensus is a many solution problem. Like there are bajillion consensus algorithms out there.
But we have chosen one, right? We have chosen one. It is LFBF.
We have chosen
it, so it's done. It's done in the sense whatever APIs it gives us, we'll use them and we'll say whatever LF does, that is our consensus.
That is correct. Yes.
So we don't have to invest more time than understanding those APIs and implementing those APIs. And I understand that might not be straightforward, but it has been done by other people, so we should be able to learn from that.
Right. I want to make, so Suhindra, I just want to make sure this call is focused around answering people's questions about blockchain and not so much focused around like, dates and deliverables, which that's important. It's just outside this call because like not everyone, right, wants to hear about all that. That's good for me, Chris, you, Steve, et cetera.
Yeah,
so,
you can thank me for throwing things sideways. Sorry.
Yeah, no, that's what you're here for, Steve. Throw everything sideways. So let's just stay focused. And if nobody has any other questions about blockchain, we can conclude. But again, Suhindra, I know that you continue, to seem to be missing some details, and I want to make sure you get it all so that we don't. Suhindra, it's essential that you no longer have any confusion around blockchain.
Correct. Yeah. No, thank you.
Like you have to be fully understanding of how these pieces are moving so that when we say, hey, we're doing this, it doesn't come like a strike of lightning out of the sky.
Yeah.
So that with respect is on you to ask questions now.
Yeah.
On Abhijit, I'll give you I'll let you speak in a second. In Friday's meeting, when we reviewed the Aleph code that was merged into main, I had shared some of the key APIs that we implemented to interact with the consensus engine. So that code that interacts with Aleph has been merged in, right? So we are moving, and hopefully now that some of these bottlenecks about understanding about what a blockchain is, what consensus is, what the libraries we're using doing, hopefully now we can start moving faster and really start working on knocking out the actual meat and potatoes of this.
Right. Look to the rest of the development team, all you need to know is the API entry points, right? Add transaction and add block listener, and that's it. Aleph and all that other crap, immaterial. You guys don't need to know anything about it. You know what? I know we're using live P2P, but I don't know shit about it, right? Because I'm assuming that's going to be handled for me, right? So Aleph is a low-level detail that if we've done our jobs correctly, you will never know about and you will never care about.
Abhijit, you had raised your hand.
No, I rose my hand previously. I put it up, and then I forgot to lower it.
Oh, that's okay.
Okay, wait, just a minute. So Christian just spoke about certain endpoints, right? Are they hooks in Rust, or do we have any clue about it? Like, do we have a plan? Yeah.
Say that again. I missed the first sentence. I heard blah, 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 hooks in
okay,
Rust.
my question is this. you said there are Aleph endpoints which we can access, right? So
No.
do you know any Rust implementation or any Rust crate which we can use? Okay.
No. No, you somehow you misunderstood me. There are no Aleph endpoints. Aleph requires us, the blockchain implementers, to implement some trait functions in order to integrate with it, which we have done and will continue to modify as necessary. But there are no endpoints. There's no like RESTful endpoints or anything like that.
No. I meant by access points. That's what I meant by endpoints, but sure.
Christian, if I may. Abhijit, what you had missed was at the beginning when Christian showed us the blockchain API. There's this notion of like submit transaction where you pass the data and you pass a Lambda and you get the result eventually. So like we are going to be providing the API, and if you like, we can share that with you afterwards.
Understood. Thank you.
Yeah. So block and transaction settling is asynchronous, and you give us a Lambda, and that'll be called when the block and transaction settle. That's it. Okay, I'm going to end this call since it's everyone's gotten their questions out. Suhindra, do you have any more doubts or misconceptions that we can answer?
I think as it is presented, I understood the boundaries. I'll have more questions in a few. Like I'll let this sink in a little bit.
Okay. All right, Steve, do you have any questions?
No, this was a good overview. I think it helped with the details on how it's being stored in the block and how the consensus algorithm stuff fit in. So thanks for putting this together, Christian. It was good.
Thank you.
All right. If you want to drop any more grenades, we still have 5 minutes, but
thanks for,
all right, guys,
for giving us this overview, Christian. I'm not going to lie. I was very confused as to what was the consensus algorithm versus what is the blockchain. And this helped clarify that a lot. So thank you.
Good. Yeah. The blockchain is literally just a data structure that gives us cryptographic, assurances. Aleph is the consensus engine that allows us is what tells us when we should add something to the blockchain. And that's it.
No, I get that now. I didn't understand that distinction before.
I got it. I was just summarizing it again. All right, guys, thanks. And if you have any other questions, of course, you can direct them to me. Suhindra, if you need another one-on-one, I'm happy to give you as many as you need.
Thank you.
Okay?
We'll probably need one. Yeah, thank you.
Thank you, guys. Take it easy. Bye.
Thank you, bye.
Bye.